or if you're having technical difficulties. Also, if you're having technical difficulties, feel free to call our main office number, 949-282-0123, and that's on your screen. And somebody will try to work with you to assist you if you're having any technical difficulties. Also, on your screen, you should be seeing a presentation, a PowerPoint presentation on the left-hand side, and the upper right-hand side, you should be seeing a video image of the speaker, myself. And you're welcome to grab the sides of that speaker window if you want to expand or contract it, depending on whatever fits best for your screen. So without further ado, I think we'll go ahead and get started. Again, as I mentioned, we're going to focus on a quick overview of the CalARP program in California and also the federal RMP and PSM programs. Actually, in California, it is administered by CalOSHA for PSM. We're going to talk about upkeep requirements, which tend to trip up folks a lot, and also common program deficiencies. Oh, change out the mics? Okay, hold on for technical fixes, please. Okay, mic's on. Is that any better? Okay. All right. So anyway, key topics today: reviewing the program requirements, upkeep requirements, deficiencies, and I also want to focus a lot on something that trips people up a lot: recommendation follow-up. Recommendations are action items that are generated by these safety programs from a variety of different mechanisms, whether it be compliance audits, incident investigation, or process hazard analysis. It's literally a smoking gun in terms of something that a team said that we should do this, and if it's not done, it's an easy target in terms of citations and other problems if you're being audited by regulatory agencies. And also talk about most common program deficiencies, the things that really trip you up. I'll be interjecting a lot of specific ones throughout the presentation and also overviewing all of them at the end. So let's talk about some of the requirements. For CalARP and the risk management program submittal that is a little bit more extensive in California and then summarized in the RMP e-submit that you send to the EPA. There's a basic submittal. You have to do submittals, updates based on 5-year periods if nothing's changed or if there are changes in the process or the structure of your organization. They have to be done more frequently. A management program to make sure things get done properly and keep up with it. A hazard assessment to characterize the overall consequences of the events. Prevention programs to prevent the actions from happening in the first place. And emergency response program in case something does occur to mitigate the effects of those consequences. Let's take first a look at some more simple level of program. There are 3 main flavors of program associated with both the federal risk management programs and the state accident release prevention program in California that's called CalARP, and that's program 1, 2, and 3 in increasing level of complexity. Program level ones are fairly simple and they involve a fairly straightforward hazards analysis. So I'm going to spend most of our time focusing on the things that trip people up a lot for program 2 and program 3 facilities. Program 2 is the least complicated program. It involves, on the upper right-hand side of your screen, the hazard assessment so you can understand the nature of the releases and how bad they are. In California, seismic safety assessments and walkdowns. One of the main external events that can potentially impact your facility in California is seismic. So there are specific requirements and guidelines for the CalARP program for that. So formulating your submittal and also putting together your emergency response program. Now, the big difference between a program 2 and program 3 facility is the prevention program. As I mentioned, program 2s are simpler. They include, if you look at that pinwheel on the left-hand side of the slide, safety information, hazard review, operating procedures, training, maintenance, compliance audits, and incident investigation. Of course, one of your questions is, why are some of them red? They're highlighted because those are the things that get people into trouble most often, and we'll be talking a little bit more about that. A more complex program level is program 3. This is very analogous to process safety management. We'll talk more about that in a second. The same key elements of hazard assessment, seismic safety, formulating or submittal an emergency response program apply to Program 2 and Program 3 facilities. Program 3 has a more complex prevention program, more detailed, and it's meant to reflect a potentially more hazardous facility, typically. Okay, the key elements: process safety management, process hazard analysis. I'm just going from clockwise on the pinwheel: operating procedures, training, mechanical integrity, management of change, pre-startup reviews, compliance audits, incident investigation, employee participation, hot work permits, and contractor safety are all key elements of Program 3. And as I mentioned, the majority of this, the overlap between this and the process safety management programs is very significant, way over 95%, and we'll be talking more about that in a few minutes. I've also taken the liberty of highlighting certain elements in red that tend to trip people up most often: process safety information, process hazard analysis, operating procedures, mechanical integrity, and management change are the things that get people into trouble the most. And we're going to go through all these elements and identify common deficiencies and things to really look out for, very, very common elements that trip people up and result in citations. Taking the liberty on this slide, I'm not going to go through all these elements. This is primarily for your reference, for if you're a California facility, to review the regulatory locations for the federal EPA elements, federal OSHA, California OSHA for PSM, and also the CalARP program. You'll notice that all the various sections on the left are equivalent to the pinwheel we just went through. There's a significant overlap. In fact, one of the things that we've done real recently, I co-authored a paper with some of my colleagues here that provided an overview of the evolution of safety management system programs, starting with a lot of things that happened in the 70s and really came to a head with the Bhopal accident in 1984. And if you look at the evolution of what came out of that, this Center for Chemical Process Safety, which I had the honor of serving on for a few years, putting out their technical management guidelines for process safety, API recommended practice 750, and then finally in 1992, OSHA's promulgation of process safety management, and then in 1996, EPA's promulgation of risk management programs. You'll see, and also just to complement California, in the 80s they had a risk management prevention program. All these key elements that you saw on the previous slide as pinwheel items here in the section column. After hundreds and thousands of people have looked at these programs and I tried to identify ways to manage process safety, you're seeing these same elements. You're seeing the same kind of things, even from different organizations. CCPS for chemical industry, API recommended practice 750 for the petroleum industry, OSHA's promulgation of PSM, etc. All these same elements occur, and so realistically, a lot of people looked at that and realized that these really do characterize the best, most effective approaches right now for addressing process safety. So anyhow, that's why you see this common theme. That's why you see the overlap. It's not just that you've got different jurisdictions trying to do the same thing, which is true in a lot of cases, but the fact is that you've got the same kind of things that really need to be done to prevent accidents and protect the employees, the environment, and the public. I think it's worth taking a couple of minutes and identifying how we got here. Why do we have all these programs? A lot of you who may be fairly new into the process safety arena may not understand some of the background or the importance of these things. My actual foray into this field started in 1983 when I shifted from another group in Westinghouse to the process safety group, and we started applying a lot of these techniques even before the Bhopal accident or OSHA's promulgation of PSM. What you're really looking at is you're looking at very significant events, catastrophic events in many cases that result in losses of many lives or significant impacts on the environment. And whether you're talking about Bhopal in 1984, whether you're talking about a more recent, the Deepwater Horizon accident in the year 2010, a lot of things have occurred that have resulted in significant events, significant business impact, And it's really clear that there are fundamental flaws in many of those cases of how the application of safety of management systems to manage the safety at the facility was actually done. There's a common thread there, and it's very important to realize that just because these accidents don't happen every day, that doesn't mean that it's not important to constantly stay on top of your safety of your management systems program like PSM or RMP. These are things that there are potential for accidents in many cases at some of these highly hazardous facilities, and it's really important to stay on top of. And when you turn your back on it, especially if you ignore your program and don't keep it evergreen for a long period of time, that's when you're going to have to. So where we're at right now is really that have resulted in significant accidents. And that's really what you're trying to do here, is you're trying to prevent catastrophic events. And one of the spin-offs in many cases is by applying PSM and RMP and controlling these serious events, you can prevent, in many cases, lesser events. By establishing a culture of controlling major events, you can prevent smaller events, and you can maybe run your business a little smoother too. Oh, George, can I ask you to sit over here? Okay, so what are we trying to do here? As I mentioned, there's a mission. There's a need to apply these programs. And can I ask you to hit the page down key and just catch up with the screen? Okay, yeah. All right, there's a mission here to try to prevent these events and protect the employees, the public, and the environment. And basically, all these programs are trying to document that you're doing that. Are we having technical difficulties? You want to change mics again? All right, why don't you, all right, we're having some static issues on our end. We're going to go ahead and take a 30-second technology fix break. Be right back. Is this any better? Am I speaking statically today?
No, I mean, that's definitely better. Make sure that you don't fire at all.
You want this closer, maybe? Let's try that. Mic check? Microphone check? All right. Is this at least acceptable? All right. All right, let's give this a try. Let's get rolling again. There's a mission here. All of the folks who are tuning in, if you're responsible for your programs, it's important to keep up with the programs and really for this primary purpose of protecting employees, the public, and the environment, and making sure that you're getting the necessary resources to do that from a training, maintaining equipment, and also personnel perspective. And that's what we're going to be focusing on today. So let's talk about upkeep requirements first. Some of the key periodic requirements are every 5 years. As I mentioned, there's a requirement to resubmit. We'll also talk about some caveats where there may be some more frequent requirements under certain conditions. Every 5 years, you must update or review your hazard assessment to make sure that it's applicable. There's a requirement to update or review and update as necessary your hazard review, and the rule 2 there is that's the term used for program 2 for the fairly simple techniques, or the process hazard analysis if you're a program 3 facility. You're also required, if you're in California and subject to the CalARP program, to do an external events review, primarily seismic, as we discussed, with various guidebooks for seismic safety assessments, and but you also must consider other external events. Some more problems, Nicole?
Well, the sound's okay right now. For some reason, your stuff's different than the one I have. So far, I've been able to find all the slides, but I don't see that slide. And I grabbed it from the February 24th folder drive. So I don't know.
Are you? I'm going to go off mic for a second. Okay, we're going to take another 30-second technology break. Excuse me. All right. We seem to be, are we live?
Yeah.
All right. Right now, hopefully you're seeing the same slide that I am. And hopefully your room is a lot cooler than ours. We seem to also be having some temperature problems here right now. So where I left off is we're talking about 5-year updates. And we're talking about hazard reviews. Did they see this slide before, Nicole? Right. All right, let me start at the top then. Okay, every 5 years, CalARP RMP submittal, hazard assessment, hazard review, or PHA, and external events review. We just discussed that. Now you're seeing it on the screen. I'm going to pick up in the middle of the slide for every 3 years. Every 3 years, you need to make sure that you're providing refresher training to key personnel. As performance-based standards, they don't tell you exactly what training or exactly who needs to be trained. That's something that you need to define as part of your training program to make sure it's effective and meets the requirements and objectives of these performance-based standards. Compliance audits also need to be done every 3 years. A lot of people get confused and think that, oh, my regulators showed up and they did their compliance audit, so I guess I don't need to do mine. Not true. If a regulator shows up, they've got their own mission. They can show up for half an hour and do a quick walkthrough. They can stay there for 30 days and do a detailed assessment. But that's still their mission. It's your responsibility to monitor the health of your program and make sure things get done. That's the objectives of the compliance audit. It's on a 3-year cycle, which is totally different from the 5-year cycle that's being done for hazard review and process hazard analysis. So even if you just updated your CalARP RMP submittal last year, if your audit was done 2.5 years ago, it's time to start thinking about auditing your program and making sure that you've verified the adequacy of implementation and that it's effective. And also in California, there's a requirement for hazardous materials business plans to be resubmitted on a triennial basis. Annually for these programs, operating procedures need to be reviewed and certified as adequate. Emergency action plans or emergency response plans, they also need to be updated. They certainly need to be reviewed. The timing is a little bit looser, but best practices, and there's some general requirements for updates on an annual basis. And also hazardous materials inventory updated may be required on an annual basis. Other update requirements are non-specific. Safety information, or for if you're a Program 2 facility, or process safety information if you're a Program 3 facility, that may need to be updated much more frequently if you're making changes to the process that affect this safety information. Maintenance, mechanical integrity, whether you're different terms and different levels of detail depending on whether you're a Program 2 or a Program 3 facility. Obviously, you need to do maintenance more than once every 5 years. It may be very frequent for components that are safety critical, maybe less frequent for less safety critical components or things that are high reliability or don't have quite the consequences as others. You have to decide based on OEM information, based on the equipment, based on its service, what exactly is required and how often. Incident investigation, hopefully you don't have to do those. But if something occurs, you have to start an investigation within 48 hours. We'll talk more about that shortly. And it needs to happen right after the incident. So there's no specific requirement, but it may need to be implemented periodically. So all these programs, PSM, RMP, CalARP, cannot be something you do once and put on the shelf. This is something that requires continuous update and continuous attention. Management change, required for process safety management and Program 3 facilities. Anytime there's a change, you have to have a mechanism for evaluating the impact and getting any revised information out to the people who really need it. Pre-startup safety reviews linked to management of change. Also, if you're down and you've made changes, you have to do a PSSR to make sure you've implemented things properly before restart. Hot work permits, obviously, whenever needed. Contractor safety and qualifications are going to be have to be done fairly frequently as personnel change, as your contractor changes, etc. And also in California, there's an injury and illness prevention program. And in big red letters at the bottom, any non-incidental changes in design or operation may be required for these programs. I've put together a fairly handy table on this slide of when things need to be done based on the specific program elements, and a lot of the key things on the right are color-coded so that you can get to them on a 5-year, triennial, or annual basis as necessary. So let's talk about the different elements and some of the common deficiencies associated with those that you'll want to look out for. First of all, for the submittal, you want to make sure that the submittal gets done by the anniversary date. If there's a change in inventory that affected your off-site consequence analysis by a factor of 2, that also you're going to have to do a resubmittal. Ownership changes, emergency contact points, CalARP, RMP coordinators, the EPA, and your CalARP coordinator, your local CUPA, want to know who to talk to, who to contact in emergency. So as those things changes, they'll need to be promptly notified. A lot of these things have a 6-month clock. For a lot of these things, the amount of effort to change them is fairly small. You'll definitely want to be responsive. Keeping your CUPA happy, keeping them informed is a good way to maintain that positive relationship that will help improve things at your plant site and make it easier for these regulatory programs. And of course, if you have a reportable incident, you may have to do a resubmittal. Let's talk about the hazard assessment elements. The off-site consequence analysis for Program 2 and Program 3 facilities includes worst case and alternative scenarios. Only the worst case scenario needs to be looked at for Program 1, but we're not really focusing on that for this presentation. And in general, you'll want to use hazard assessment, EPA-approved dispersion models, and make sure that you've got a report that you can find things and update them fairly easily. What just flashed on your screen is a little picture of RMP Comp. That's a EPA-approved software package, very easy to use. And although it tends to overpredict consequences for toxic gas releases and also for flammables, it's EPA-approved and certainly errs on the conservative side. So if it works and if it doesn't impact what you do at the plant site, why fix what isn't broken? It's very easy to use, and it's, like I said, very defensible. We usually recommend keeping things simple unless you need to make things more complicated. In-house, we do have capabilities for very high-end dispersion modeling packages and things that do very detailed analyses, but you don't always want to use those because then it requires more effort, and unless you're going to get insights that actually help you with your program or help defend an issue that you may be having with off-site receptors, then there's really no need for that in most cases. So let's take a look at some common deficiencies here. Not getting the submittal done, that's pretty basic, but a lot of people, the dates slip. At the plant site, they have a change in coordinators. The new person comes in, they put PSM or RMP coordinator in their resume. The hiring manager gets them in, and they're all excited. They got a PSM coordinator. A lot of times people don't know what they're doing, and they're getting into this kind of fresh. And if they're not, if they don't have all the records, if they're not watching what's going on, it's really easy to miss these submittal dates. Also, not having a management system in place, having specific written assignments of responsibility is critical. That's one of the things that people are going to look for if they come in to audit your facility. If a regulator comes in, they're going to want to know who's in charge of programs and how are you monitoring that the things are getting done. For the hazard assessment, common deficiencies, not documenting your basis for scenario selection, and also failing to update population-sensitive receptors and maps on revalidation. Those are common deficiencies, real basic things. They tend to slip through the cracks, and a lot of people tend to miss them. Let's talk about process safety information on your left, which is for Program 3 facilities, and safety information on your right. A lot of the key things that are needed, and I'll focus on the process safety information on the left, toxicity information, thermal and chemical stability data, mixing issues, documentation you need, block flow diagrams, process chemistry, maximum inventory, maximum intended inventory, safe upper and lower limits, and also looking at consequences of deviation. Other process level information, materials construction, P&IDs, electrical classifications, release system design and design bases, ventilation system design, design codes and standards that are used, material and energy balances, and safety systems that are applied in their design bases. These are things that are very fundamental. A lot of times they don't change a lot, so once you compile them, you're in pretty good shape. But, bless you, if you change out a relief valve, if you redesign, repipe your process equipment, you may need to revise set points, operating procedures, P&IDs, or anything else that is associated or has in it key process safety information. So you need to have a management program for making sure this is updated so the people who need this information has it and that it's current. Keeping up with this stuff for many facilities where changes are being made can be very non-trivial. It can require a lot of effort. If you're in charge of managing these programs at your facility, try not to underestimate the amount of your personal time and or resources that may be necessary to keep up with these things. Couple of quick examples that I put in your package of a process flow diagram. It's meant to give somebody an understanding of what's going on at a glance of where all the hazardous materials are, general inventories, types of equipment they're in, and how this process works. In more detail, P&IDs, and I provide you with a little example there, they have more information about set points, component IDs, design pressures, etc. A lot of people ask, well, what goes on a P&ID? In fact, we've actually given frequent P&ID and process safety information classes that we've done by webinar and also in person. A lot of people do ask these things, but it really depends on what you need. And you've got to decide at the plant site, although there are a lot of standards, there's ANSI standards and things like that that allow you to determine what goes on a P&ID. It's really meant to be the embodiment of the kind of information you need when you're evaluating hazards at the facility. And that's where the rubber meets the road, is what goes into a P&ID. It should encapsulate all that basic information so that if you're doing a process hazard analysis, most of what you need is in front of you in a form that shows the interrelationship of these various safety characteristics. Common deficiencies associated with process safety information. P&IDs not updated, not there, not reflecting changes that have been made to the system or are not complete. I have to tell you that after doing this for 28 years, kind of, sort of, I have never seen a P&ID that's 100% accurate. Now, usually when I start a HAZOP study or a process hazard analysis, the minor errors are small enough so it really doesn't affect what you're doing or the ability of the team to work on it. And one of the spin-offs of the PHA or HAZOP study is actually marking up the P&IDs and getting these folks together to make sure they're current. This is very important to be done right. It's a critical part of your process safety information, It's hard to do. A couple minor glitches here and there probably are going to be inconsequential. But you know, if you're having complete missing drawings, if they're totally inaccurate, or you didn't field verify them, and you start your PHA, I can guarantee you that you're going to spend more time and aggravation and wasted effort, especially if you're hiring a consultant to come in and facilitate your HAZOP study, in trying to work around big chunks of missing data than if you just spent the effort up front and updated the P&IDs. Second bullet, not filing, managing, or being able to locate key process safety information. Regulator shows up at your plant site and they want this stuff. If you can't find it easily, they've got to ask, well, if you can't find it easily, how valuable is that? How much is it used? How good is it? And in terms of its effect on your program. Relation system design or design basis not documented, that's very common. Easy citation there, and a lot of times they don't change very much. It's just a matter of filing it properly, being able to locate it. For all this process safety information and various elements, we usually recommend, or we set up for clients, an electronic universe, if you may, of something on your local area network where you've got certain directories that are key to these various elements of PSM and RMP and CalARP, where all this stuff is pigeonholed. If you got large copies of paper documents, gosh, an accident, somebody misplacing them, accidentally throwing them away, you want critical information scanned and also archived electronically, and good backups made of these electronics. There are ways to, even though it's a lot to do, there are ways to handle this properly. And again, we usually recommend that doing something that makes it very easy to find and also archives it very thoroughly. A lot of things that we do too, most of you use Microsoft Office as an interface. It's really easy to set up an HTML hyperlinked front end that actually links into these documents. And gosh, if the regulator comes in and you can like put your hands on this information very quickly, they're going to feel real good about your program, and your audit is going to go a lot smoother. Fourth bullet, compliance with recognized and generally accepted good engineering practices has to be documented. Electrical area classifications not being documented is very common. That's something you may want to get on top of. And also chemical reactivity hazards, if they apply to you, and also various hazards not being documented. So what I'd like to do with all these, and it's a little difficult to do with a webinar, is I'd like to run through a quiz that we would give if we were doing this at a plant site and point out a couple of key elements. Process safety information being up to date prior to conducting the process hazard analysis, absolutely true. You want to make sure this stuff is up to date. Any effort you spend beforehand in field verification, double checking the drawings, and making sure P&IDs and other PSI information is up to date will save overall time and effort in the long run. Second item, material safety data sheets can be used to meet all process safety information requirements. Absolutely false. MSDS, good information, but it's just one element of a lot of the things that are required for PSI. So let's talk about the process hazard analysis and hazard review. PHA is for Program 3, hazard review for Program 2. Objectives, identify hazards of the process chemical, operation, and external events that can affect the facility. Look at risk to property, health, and life. List the worst case consequences, identifying the safeguards that are in place, and making sure that you've got an objective method to measure the effectiveness of those safeguards and make a determination for additional safety features. These are usually done as part of a team. Now, the type of approach is very flexible. I've put together a spectrum of the kind of PHA tools that you might see applied. On the left, you'll see things that are much less effort, but don't really yield the insights of more complex tools. Less effort, fewer insights for a simple process may be just fine. So if you get a very simple process, a what-if approach or checklist approach, it may be just fine. If you got a more complex chemical process, something like a HAZOP study, or if you're trying to make the tough decisions on the adequacy of your safeguards, even applying a layer protection analysis or limited and focused applications of quantitative risk assessment like fault trees or event tree analysis might be very useful. I used a lot of conditional words there. In the wrong hands, ALOPA, fault trees, quantitative risk assessment can be a nightmare. If it's focused and meant to address specific problems and specific decisions, they can be very helpful and very effectively applied. Okay, common deficiencies for the PHA. Not doing 5-year updates on time. A lot of times, too, people play games. A PHA might have been done in February 1993 and documented, and the report's dated in August 1993 because somebody got busy and didn't do it right away. Well, August 1998 is not the time for your next update. You really need to key it on when the team meetings were done because that's the encapsulation of when you actually did the analysis. So making sure these 5-year updates being done on time, it's an easy citation and easy for a regulator to check if it's not done. Recommendations not closed or closure not documented. If you've got a recommendation from a team in terms of how to improve safety and you don't follow through with it, like I mentioned the term smoking gun before, it's an easy citation that can be picked up to have open action items like this. Human factors, facility siting not addressed in the report, facility siting not using current design codes and standards, not using an industry-accepted approach for your hazards analysis, inconsistent consideration of scenarios and risk ranking, or not risk ranking at all, or something that a regulator will often pick up on, and also not addressing external events, and especially for California seismic, that's a common deficiency. So let's look at a couple of key points in the form of a quiz. The what if and has up study techniques are the most commonly applied for PHAs. Absolutely true. For most processes that are out there, a what if for the simpler level process and a has up study for a more complex one are your basic process hazard analysis elements that get applied most often. And as I mentioned before, focused application of LOPA, focused application of quantitative risk assessment can be very helpful in the right hands. Second bullet, required expertise for the PHA team includes engineering, operations, and somebody familiar with PHA methodology. Absolutely true. Those are specified in the regulations. And that doesn't mean that you have to go and get a consultant. Risk management professionals is an engineering consultancy, but I have to tell you that in a lot of cases, if you've got the knowledge on site, if you're comfortable with it, want to do it yourself, and really get into your program, that can really reinforce the application of a very strong program at your plant site. And there's nothing in these requirements that says you have to go get a consultant. We do a wonderful job for our clients. We take a lot of pride in it, but it is not required that you need to get a consultant for these things. Other things to think about for PHA, closure of the PHA recommendations is the responsibility of the facility, and the auditing agency would typically not be inquisitive as to status. Well, two parts to that. First part is true. The closure of recommendations is the responsibility of the facility. You're not waiting for the regulator to show up and verify and have that person help you close recommendations. And when they do show up, they are going to be inquisitive, very much so, as to what you did with those recommendations. Coming in from the outside, they're not going to know as much as you do about your program, about your plant, so they're going to want to rely on whether or not a team of experts, what they identified, what conclusions they came up with, and then how you handled those findings. Second bullet on the slide, PHA revalidations are required at least every 5 years. That is true. A revalidation, a minimum 5 years if nothing's changed, more frequently and maybe even infused into the management change process if there are a bunch of changes. Let's talk about operating procedures. There's a number of procedures that are necessary to handle different operating modes. Initial startup, normal operations, temporary operations, emergency shutdown, emergency operations, normal shutdown, and startup following turnaround. All these things need to be addressed at your facility. Now, can you combine them? Can different operational steps apply to different operating modes? Absolutely. But not having these things identified and not dealing with them in the operating procedures, people wonder whether or not you really thought about it or are telling the operators how to deal with these kinds of operating modes. Operating limits, consequences of deviation, steps required to correct or avoid deviations need to be included, various safety and health considerations, like material properties, precautions to prevent exposure, and also various control measures if there is contact or if chemicals are released. are very important to include in operating procedures. These things are important and will be looked at during an audit by an outside agency. Common deficiencies for operating procedures, the procedure is outdated, or you haven't performed your annual review and certification. Just reviewing it is one thing. Most of the times there's a sign-off sheet right in the front by somebody in a responsible position that it was reviewed and certified to be current and adequate. Second bullet, written procedures not synchronized with operator actions. I don't know how many times I've been to a plant site and, you know, just when you're spot checking or looking at some of these key PSM elements, you get a copy of the operating procedure in your hand, then you have the operator actually show you what he or she does, and they're not the same. All right, a lot of times the operator gets the procedure and goes, like, I know what I'm doing anyhow, and just kind of ignores it. What you want to do is have the operating procedures capture those best practices from your personnel. Why do you want to do that? Consistent application of best practices is going to be safer. And from a selfish perspective, if you're a business, gosh, if you got an employee who's retiring soon, you want to capture those insights in how to operate it efficiently, effectively, and safely, and get them into your operating procedures. Third bullet, each phase of operation not listed, common deficiency, emergency shutdown procedure job assignments not clear, temporary operations not included, acceptable alarm set point ranges not documented, or procedures not in the language of the user are all common deficiencies. Now, if you've got a bilingual or multilingual staff, do all procedures need to be in all languages? No. What you need to do is verify that you're meeting this performance-based standard, that they understand how to operate it safely. That can mean that you keep the procedures in English and help them with their language skills, or it could mean that you may want a couple of different flavors of procedures depending on language requirements. In fact, we've done that in some cases at some facilities in California. Actually having procedures only in Spanish makes sense, and that's manageable. So let's do a little quiz here. If there have been no changes to the system, there's no need to certify operating procedures each year. False. Okay, whether there have been changes or not, you have to have somebody sign on the dotted line that they've looked at it and that they're adequate. Contractors are not required to follow the facility operating procedures. False. A lot of times, contractors and plant personnel, other than the uniform they may wear or the Nomex they may put on, are basically interchangeable or doing very similar things. If the procedures need to be followed by operators, also by contractors. Let's talk about training. Okay, training has to address operating procedures and various safety, health, maintenance, and emergency response issues. You need to make sure that training includes safety and health hazards, emergency operations, safe work practices, safety systems, operating limits. And the records, let's keep that in mind. The records have to identify the individual who's trained, the date of the training, and how you verified that they received the training and understood it. Basically, comprehension training. Common deficiencies for training, documentation that demonstrates that training is performed, not available. Auditors, regulators are going to be looking for that. You want to keep really good records of training. Training records don't include the means used to verify the employee understood the training. It's one thing to go through and send them to a class. Did they understand what was going on, or did they just sleep through it and not really get what was going on? PPE, procedures and training documentation not available. Training not in the language of the user. Again, performance-based standard. Training, procedures, all these things need to be understood and acted on properly. And also training not encompassing maintenance procedures. Let's go over a couple of key points. Refresher training on the applicable facility operating procedures is required every 3 years. True. Training records should document the means used to verify training comprehension. Absolutely true. You need to have some mechanism. It doesn't have to be an extensive 5-day test. It can be that they walk around the plant site and you're actually working with the operator and verifying by visual observation, and a supervisor or more experienced employee signs off. Lots of ways to do that for a performance-based standard, but you have to have some mechanism that you validated is adequate. Let's talk about mechanical integrity programs for Program 3 or maintenance programs for Program 2. All of these describe the process and safety equipment, preventive maintenance activities, and inspection schedules. So inspection, testing, maintenance, key things that are necessary for all these programs. One of the things you can do, you can go home and have your sprinkler system in your yard break or be operating sporadically. That's your business, and it's a low hazard kind of issue. For a highly hazardous facility, a fix-at-failure maintenance strategy is not acceptable. Well, it's not acceptable for at least equipment that's associated with the hazardous materials and or critical safety systems. You have to have some program to verify or validate how much effort is needed and when, and have a mechanism for going through it and verifying that it's reliable and that the equipment's available when needed. You have to have a preventive maintenance program based on manufacturer recommendations. Excuse me. And if you're using a contractor, you must develop a written schedule of what they're replacing, overhauling, cleaning, and at what frequency. So even as a facility owner, even if you task out maintenance, you've got to keep records and make sure they're doing the job properly. This slide is a little busy. This emphasizes the fact that there's lots of ways to skin the cat here. There's lots of different mechanical integrity programs and how you implement it. Simple on the left is memory, freestyle. In a lot of cases, it's just not adequate anymore. On the right, you're looking at computerized maintenance management systems is where most programs have evolved into, and a lot of them are either computers at the plant site, a lot of times using very expensive software. A lot of the more effective programs are web-based and go through and retain the documents in an archive form and do a lot of hand-holding to make these things very easy. Our personal packages, PM Plus and also PS Solution, use a web-based mechanical integrity interface, and that's where a lot of them are going now. It simplifies training, and also it's a lot lower upfront costs. Something to keep in mind for mechanical integrity is it's not static. It's very much the epitome of an evergreen program. You define requirements, you manage the program, develop procedures, have training, do your inspection, testing, maintenance, and repair, have documentation that you've done that, and you have a feedback mechanism. Is it working? Am I like inspecting something annually? And I was at a facility one time, and they were doing wall thickness testing on an annual basis using non-destructive examination. And there really weren't any, it was a very benign process. There weren't any changes in wall thickness. And it was easily justified that you could inspect that equipment much less frequently and save a lot of money. On the other hand, some equipment that's breaks down a lot, and that requires a lot of attention may need inspection or maintenance much more frequently. So again, performance-based standard, you're devising your mechanical integrity program to reflect the equipment and what it's trying to do. Common deficiencies, written procedures not being available, not complete, or not implemented. Inspections or maintenance not occurring at the frequency consistent with industry standards or best practices. Come back to that in a second. Equipment deficiencies not corrected in a safe or timely manner. If something's broken and you just go like, okay, we'll leave it broken for a while, that's not acceptable. I'll give you a good example. I was walking through a water treatment facility that was using gaseous chlorine. It was located in a building. They had a caustic scrubber on the outside, and we actually did a full HAZOP study, and we kept taking this caustic scrubber as a recurring safeguard that was very, very important. Well, I usually like to do walk-downs as part of the HAZOP study whenever I facilitate. So we went for a walk-down, and as I walked down the facility, I was walking past the building, I looked down the pit, and here was the main caustic recirculation pump disassembled. And I said, wow, how long has that been like that? Oh, about 4 months. And basically they weren't correlating the fact, and I said, well, is that acceptable? He said, well, it never runs. And so several things there. First of all, it never ran means that they weren't testing it to make sure it was functional. And secondly, just because it's a standby piece of safety equipment that's not normally operating, like a relief valve or this caustic scrubber, doesn't mean you don't need to make sure it's 100% reliable and there when you need it. So you've got to fold things like that into your mechanical integrity program, maybe put limits on how long critical equipment can be out of service, and making sure that if there are deficiencies that they're corrected in a safe or timely manner. If you're relying on a contractor, you've got to have a written schedule and keep records. And whether it's contractor records or your records, they've got to be kept, they've got to be archived, you've got to document your mechanical integrity program. This is an area that a lot of people get cited. That second bullet where you're not doing your inspections or maintenance on a frequency consistent with industry standards or best practices, it goes beyond that. If your own program said that you should look at this or do something every 3 months, and you're not doing it every 3 months, and there are records there to verify that. If you're not doing it every 3 months, that's an easy citation for a regulator coming in. A couple of key points. A relief valve is one type of equipment typically encompassed by mechanical integrity programs. Absolutely true. It's one of your key safety devices for overpressure protection. A PHA is another PSM RMP element which can provide a basis for the mechanical integrity program. Absolutely true. When we set up mechanical integrity programs, we'll look at what safeguards are accredited, we'll look at what causes triggers significant events, and we'll look at the risk ranking and how bad the consequences are to fold that into importance values for your mechanical integrity program. And if you've credited a key safety feature in your PHA and you don't have some mechanism for validating reliability in your mechanical integrity program, that's an easy gap that could result in a citation. Third bullet, mechanical integrity is a regulatory requirement of RMP Program 3 facilities. Correct. Maintenance is the term for Program 2. Fourth bullet, mechanical integrity program and its implementation must be documented. Absolutely true. Computerized maintenance management systems, that's what CMMS stands for, must be used for mechanical integrity program implementation. No, it's not true. Although most people do now, it's kind of considered best practice, and it's actually much more efficient in terms of staying on top of your program. It's a performance-based standard, so however you do it, if you got a paper way of mechanism for doing that, if you got a master calendar where you write in when things need to be maintained, as long as it's effective, that's what these performance-based standards are all about. Management of change, it's designed to make sure you have a safe and systematic method for monitoring and managing changes to the process. You're identifying the technical basis for the change and make sure the changes have been designed using best practices. You're making sure that modifications to procedures also address changes to process safety information and that all the documentation has been updated. And you also want to make sure any of these changes get communicated to employees that may be affected. Who's an affected employee? You've got to decide, but you've got to at least think about how this impacts folks. This is a very busy slide that is for your reference only, that identifies an overall flow chart for how to do management of change. Common deficiencies for MOC. Not having a procedure not current, or not using it. Happens a lot. You know what? Make sure that it's part of your culture. Another part of this is usually PSM Overview Training is a good idea annually, just to keep these programs fresh, because process safety management, CalARP, and RMP, more than a lot of programs, really affect a wide range of employees. And what's the biggest element that affects most people at a plant site, whether they're in an office or out in the field? Management of change. Everybody's got to be looking out for changes to the organization, to the equipment, to the process that are not in kind. Basically, things that are different from what you're doing, and be thinking about, hey, this impacts the management of the program. Hey, this impacts the safety of the equipment. Okay, everybody should be thinking about that. So when we do annual PSM refresher training, we usually emphasize the MOC program. Second bullet, prevention program documentation not updated to reflect a change to the system. It's a lot of work. Okay, let's be direct about this. It is a lot of work, but you've really got to think about what documentation is updated and follow through with it. Key thing, as part of the MOC process, employees and contract employees whose job tasks are affected by the change must be informed and trained in the change prior to start of the process or affected part of the process. A lot of words there, absolutely true. You've got to go through and make sure all the repercussions of this percolate through your PSM program and to employees. Talk about pre-startup safety review. It's conducted for all new process construction and modified processes to make sure the system is safe for initial and continued operation. You confirm that elements of the MOC process have been completed, and you ensure that recommendations have been closed prior to startup. you're going to see this issue again. Recommendations. You're going to see this come up over and over again, and you'll see why in a few minutes. Common deficiencies for PSSR: not having written procedures, not completing the documentation, keeping it on file, following the implementation of MOC, and not completing it and signing off until after startup. There's a little bit of give there. That's not always a citation item, but if you don't do it on the spot and before startup, people have got to, a lot of times it just never gets done, and people have got to wonder how seriously you're taking your program. Pre-startup safety review must be completed for all process modifications, including in-kind changes. That's absolutely true. Even if you're doing an in-kind change before you start up, you want to run through your PSSR checklist. Compliance audits. PSM and RMP have nearly identical requirements for this. You've got to certify compliance every 3 years, document findings, address deficiencies, retain 2 of the most recent audit reports, and you want to make sure that you can address this by developing checklists for technical compliance and the effectiveness of implementation. It's not about just checking the box, do you have an operating procedure? Do you have a mechanical integrity program? The compliance audit is about evaluating its effectiveness. There's a real quick example of a checklist. Nothing real magic here, and there are several of these that can be downloaded off of the OSHA and EPA websites for how you apply and go through and conduct your audit. Common deficiencies on compliance audits: lack of follow-up on recommendations, not completing it every 3 years. A lot of people get confused about these different 5-year, 3-year cycles. One of the interesting things about for those of you who are in the offshore facility business, like offshore oil platforms, there is basically an analog to PSM that's just been promulgated called SEMS, or Safety and Environmental Management Systems. What they did when they promulgated that is they looked back at a lot of the problems that people were having with PSM and RMP programs with these 5-year cycles, 3-year cycles, and annual cycles, and they simplified a lot of them, unfortunately, in favor of the more frequent, or the program itself, or the regulator, if you may. Basically, they synchronized the hazard review, submittal, and also the audit to be 3 years, so people wouldn't get confused, because this does cause a lot of problems. People lose sight of, okay, what part of the cycle am I in, and they don't do their compliance audit. And it's the year 2011. For those of you who did their initial submittal in 1999 and stuck with the compliance audit schedules every 3 years, with their first compliance audit in 2002, next 2005, next 2008, 2011 is the next audit cycle for a lot of folks. And the regulators are getting a little more aggressive. When they start looking, they're going to find a lot of people just miss this because they get confused about the cycles, personnel turnover, and they have a hard time managing these kind of things, which we talked about management issues earlier. Third bullet: compliance audit of the program, but not the supporting documentation. You've got to look, you got to dig. What we do for compliance audits is what most folks do too. You do a broad brush of everything, and then you really drill down into key areas to make sure things are done properly. A couple of key points. All past compliance audits must be kept on file for the lifetime of the process. Not true. The last 2 are adequate. Most people will keep all of them on file because it's not a big deal. Second bullet: the 5-year update satisfies compliance audit requirements. Absolutely not. You're doing different things for your 5-year update, and you're making sure documentation's done and your PHAs are updated. You're not doing the thorough monitoring of the health of the program like you're supposed to do for compliance audits. And third bullet: an audit by an external agency counts as a compliance audit. We talked about that. No, that is false. They're there for their own mission, for their own objectives. That does not count for your responsibility to monitor the health of your program. Incident investigation. Hopefully you never have to, I really hope you never have to do this. But if you do, you've got to make sure that any incidents are investigated and reported, including near misses. What's a near miss? Something that could have occurred and propagated to something much more significant. Well, that doesn't help too much. Let's give an example. Let's say you've exceeded you've challenged the design pressure of your vessel and a relief valve opens up. Well, the relief valve is a key safety device that prevented something that could have been a lot worse. That's a near miss. Whatever events led up to challenging those design limits on that pressure vessel and the relief valve to open are things that you want to conduct an incident investigation for and make sure that you're not challenging your ultimate overpressure protection device, which is your relief valve. Second bullet, initiate the incident investigation as promptly as possible, no later than 48 hours. There's a lot of reasons for that. Most of it's for the benefit of the facility and getting the information as soon as possible. Third bullet, the report should be reviewed with all affected personnel, including contract employees. Again, affected personnel, performance-based standard, you've got to decide, you've got a lot of latitude to decide, but you have to have a basis for what you're doing. Examples of near misses, I talked about the relief valve. If everybody knows what happened in the Gulf of Mexico last year, if your blowout preventer actuation is necessary, that's not a normal type feature. You want to identify what's causing or what's challenging that. Fouling of equipment or repeated premature failure of controls and devices, those also could be near misses. Incident investigation, the report needs to include the date of the incident, when the investigation began, describing the incident, and what factors contributed to the incident, and what recommendations may have come from the investigation. Common deficiencies, not doing the incident investigation correctly. You don't need to hire an expert, but sometimes an outside pair of eyes for serious events can be very helpful, and there are a lot of people who have various expertise and approaches that are very helpful. Not forming the team within the first 48 hours of the event, lack of follow-through on recommendations. I think we're going to have a quiz question at the end of this in terms of how many times this bullet comes up as a deficiency that causes trouble for people. Fourth bullet, findings not shared with affected employees and no investigation or documentation of near misses. These are fairly self-evident, but these things require a lot of effort and they trip people up a lot. Okay, a little quiz. Incident investigation procedures only need to be implemented when the system damage is greater than $50,000. It has nothing to do with money. This is what could affect the release of highly hazardous materials or a significant event at the plant site that can affect employees, personnel, the public, or the environment. So there's no budget cap or anything associated with that. Second bullet, the incident investigation must be initiated within 48 hours of the incident. Absolutely true. Employee participation. As part of the program, it is required that employees are consulted on the conduct and development of the program elements, and employees need to have access to elements of the program. Most good companies would just do this as a matter of course, but it is spelled out as part of OSHA, initially as part of the OSHA PSM requirements, and it's since been adopted as addenda for CalARP and RMP, and it's basically good practice and helps keep your facility safer and operating well. But not everybody has an employee participation plan and sharing that plan with employees. And employees involved in these covered processes may not know where the documentation is located. These are common deficiencies. Quiz. Employers are required to consult with employees and their representatives on the conduct and development of process hazard analysis. Yes, even though it's not specifically stated, this is a typical mechanism whereby you've got to go through and involve employees and get their insights because they're the folks in the field in a lot of cases. Hot work permits, you got to have a procedure in place for issuing the permit and for each hot work operation conducted on or near the covered process. The permit must include documentation that you've implemented key requirements, indicate the dates authorized for hot work, indicate what you're working on, and also making sure these things are kept on file until completion of the hot work operations. Common deficiencies, employees not trained or knowledgeable of the hot work permit requirements, not keeping the records, not documenting the hot work records and keeping them on file for the duration, and also not following safe work practices such as lockout, tagout, hot work permits, confined space entry, or line breaking practices. Hot work permits are not required to be completed when contractors are working on the regulated process. Absolutely false. You absolutely have to make sure permits are there, whether they're employees or contractors. And this kind of dovetails with your contractor safety program, which we're going to talk about right now. The facility has the ultimate responsibility of treating contractors and employees as people to be protected. And so the facility also has to have ensure that the contractor going to work or near the regulated process is qualified, fully aware of the potential hazards associated with the system. When you're selecting the contractor, you need to get and evaluate information on the owner and their safety performance. You want to make sure that the contractor, owner, or operator shall ensure that the contract employee is trained in safe work practices. So the facility operator and contracting company have joint responsibilities to make sure that the effectiveness of this management system is implemented for contractors. And you've got to periodically evaluate the performance of the contractor, owner, or operator, including training records and also verifying safe work practices. Common deficiencies, lack of documentation on the contractors, and also lack of contractor or visitor safety training. These are things that happen all the time. They're fairly easy to address. The biggest problems are when you've got contractors that have constant personnel turnover, or you're changing out the actual contracting company. And this contractor visitor safety training, most people are doing a pretty good job with that right now. It doesn't have to be a full-length video of everything in your plant site. People need to know what they need to know to stay safe. And so it can be a simple checklist, a 5-minute review of key emergency evacuation procedures, say for a visitor. Okay, the contractor's element of the prevention program requires that I maintain a file containing at least the following records: qualifications, safety performance, and evaluation of their on-site safe work practices. Absolutely true. These are key elements for how you manage the safety of contractor personnel. So the other key element for CalARP and RMP, as one of the 3 main elements, hazards analysis, prevention program, and emergency response, and of course this is also embedded in OSHA's PSM standard, is emergency planning and response. If you're a responding facility, you've got to have an emergency response program. If you're not responding to accident releases, you can have a simpler program whereby you want to include the stationary source in the community emergency plan, and if you've got you've got to have the operator have a coordinated response to actions with the local fire department, and you also have to have appropriate mechanisms in place to notify emergency responders when there's a need for a response. Common deficiencies. Again, if you're a responding facility and need to have a more complete emergency response plan, if your responding facility uses respirators, you need to have respirator training, fit testing for the respirator mask, fitness testing for the personnel. There's a lot of things you may need to do if you're a responding facility. The emergency response plan is at a level of that. An emergency action plan is simple actions where you're not taking offensive actions on the emergency, just defensive actions by getting personnel out of there. There's a very good paper that's referenced, well, I like to think it's a good paper, it's my paper, that's referenced at the end of the presentation that contrasts emergency response plans versus emergency action plans. Key deficiencies, key deficiencies having the wrong type of plan. If you're a responder, just having an action plan doesn't make sense, and also vice versa. Not keeping them up to date is a common deficiency. Outdated phone numbers, if area codes are changing especially, that can be a snafu. Usability of the plan. It's not a good thing to have just a long tome that's just a long monologue of what's going on at your plant. You've got to have something that's usable, easy for people to train, and easy to reference during an emergency. During an emergency, you don't want to have people running to start reading the emergency response plan. It's a training document, and it's a reference document primarily, and of course, it's something that's required as part of the program. Annual review not being performed, training not being done, physical and fit testing not being done, and also, it's as part of your mechanical integrity program possibly, if you require emergency response equipment as part of for emergency response, then it's going to be maintained and fit for service. Okay, so let's step back and take a look at the big picture. We looked at a lot of the different elements. We looked at a lot of things that can cause problems and snafus with your program. Where do most people get cited? Well, this is data from the National Emphasis Program that OSHA put forth a couple of years ago. We'll just start and go clockwise. One of the biggest things is operating procedures. Not being certified annually, not being complete, all of those things that we talked about. Process safety information, process hazard analysis, mechanical integrity, not conducting inspections and tests on time. A lot of these things that we talked about, you can see here from the pie chart, they always seem to come up because they're tough to keep up with, and it requires special emphasis on your end to do that. Recommendation implementation, actually operating equipment that's not up to snuff or not properly functional, and not completing management change. These are the top items that can get people into trouble and result in citations. The most common program-wide deficiency is addressing recommendations. You guys are supposed to keep count of how many times I mentioned that during the course of the presentation. This is the easiest thing for an auditor to pick up on when they're looking at your program. So it's really easy to address, though. Here's some tips on follow-through. Making sure somebody's assigned. When I'm doing a HAZOP study and a recommendation comes up, I like to put somebody's name on it. It encourages personal ownership. It locks the person in. It gets their attention. And it's more likely to get done if it's specifically assigned to somebody. Assigning a target completion date to each and every recommendation. If you don't assign a target, a lot of times it just gets pushed off and pushed off in everybody's busy daily schedules. Documenting that the actions taken for closing the recommendation and also labeling it as closed and the date of completion. Not complicated, but a lot of times it's not done, and if you don't do it, it's an easy potential gap in your program. Then even if the facility performs all the recommendations and you're not stating that the recommendation's been updated or implemented, that can be a deficiency. Okay, other tips on follow-through. This is quotations from what OSHA's criteria are for, hey, there's a recommendation out there, but it was during the heat of the moment at the HAZOP study, seemed like a good idea, but we don't want to deal with it. Well, there's good ways to document that. Justifications that OSHA has come up with that identify why you don't need to, that are provide a good basis for not following through with the recommendation or implementing it, are maybe the analysis was bad or had factual errors in it, or the recommendation isn't really necessary to protect the health and safety of employees. It was a good idea. It seemed like a nice design feature at the time, but it's really not necessary. Don't just think about it. Don't just like, oh, this is common knowledge. The person coming in from the outside, it may not be common knowledge to him or her. Document it. Go ahead and make a decision. So-and-so had a meeting, follow-up meeting, and we really didn't feel it was necessary to protect health and safety. Third item, an alternative measure would provide a sufficient level of protection. Hey, we looked at the recommendation in the light of day, and this is a better way of approaching our objective of maintaining that level of safety. Fourth item, the recommendation is infeasible. If it just cannot be done practically, you've got to say it's infeasible and identify it's not necessary or have an alternative. But all these are valid ways of making the recommendation go away if it's really not necessary. The key thing is making sure it's evaluated properly and documented. Let's talk about the prevention program life cycle real quick. I mentioned before that you get a lot of trouble if you do all these programs and have all these books that just go on the shelf. There's a cycle here. You're constantly implementing things, evaluating how things are done, and improving them. This is an evergreen process. Now, some facilities may require partial attention by your safety coordinator for a simple facility that doesn't change too much to keep these programs up to date. Some facilities that are constantly changing may need a team of people to keep CalARP, RMP, and PSM up to date. And that team may need support people at the plants in the facility for operating procedures, maybe keeping P&IDs up to date, or their training program. So this is all part of a process that's got to be fresh, got to be kept evergreen, and you're constantly making improvements and having this big feedback loop. I've included some references here. In fact, the top one is that paper I've referenced on emergency action plans versus emergency response plans. It's for your reference only, and I'll be glad to take any questions you might have.
I'm a little afraid to turn this on. It might have blow up, but we have one question. For the hazard assessment or the off-site consequence analysis, if nothing's changed, do they still need to rerun the analysis every 5 years?
The answer is you need to rerun it to the point where you need to look at the off-site population impacts and sensitive receptors at least. It's also a good idea to do a couple of things. First of all, when you say nothing's changed, that doesn't mean that you may not have some new insights in terms of equipment that may fail, incidents that have occurred at the plant site. Those can all fold into validating the choice that you've already made for alternative release scenarios or worst case release scenarios, and you want to at least consider and think about, are the scenarios still valid? So if you thought about it and the scenarios are still valid and you used a software program that doesn't change, most changes are just going to be primarily the population and sensitive receptors. But you do want to be thinking about this and verifying that you've characterized the analysis properly. Good question.
And one more. When we're discussing the operating procedures, we're talking about the procedures just directly related to the process, or are we talking about other operating procedures as well?
The operating, that's a good question in that I'm not going to give a real good answer. And the reason I can't give a real good answer is because CalARP, PSM, and RMP are performance-based standards. Normally, operating procedures are associated with that portion of the system or process that's associated with the highly hazardous material. So usually they're, like if you're in a large refinery, you're going to have operating procedures for a crude unit, you're going to have operating procedures for a hydrotreating unit. If you're at a water treatment facility, you'll have operating procedures for a chlorination unit. But as part of that, you're going to have the different operating modes. You would also have procedures on startup of your caustic scrubber, or what to do if it doesn't automatically start, say on a high chlorine concentration. So you're going to need, basically you need to have the procedures in place in a usable form based on, to achieve that level of safety that you want. And I hope that answered the question okay, and I'll let you re-ask a different flavor of that question if you'd like to Nicole. All right. How about here? All right. All right, well, in that case, any other questions? You've got email address, phone numbers. You know how to find us. If you have questions on how to do these things effectively, technical tips or whatever, I would encourage you to call. And we like helping people, and we also take a lot of pride in providing these kind of services. So we're happy to help out. Thank you for listening, and I appreciate the thoughtful questions, too.